Hello, welcome to this video to the introduction of how to process an audio file in VCV Rack. In this example we will use a pre-recorded audio file, a WAV file, a WAV file, that we will use as the source of our audio signal, and this signal we will analyze, creating an envelope for the signal, and this envelope will be used to cause other actions, so to trigger other events in our rack. So we can, for example, play other audio files that we've recorded, collected in a folder, so then we can randomly, or we can select one of these files based on the frequency of the file that we analyze. Or we can trigger some oscillator to play some sound, or we can trigger drums to make some hits or play some rhythms. So with this analyzed recorded file, we can do many things in this VCV Rack, and this is what I will explain you in this video. But before we will start, let's look into the results. So what you will have after you followed this video. So in the end, we will get this VCV Rack, this combination of modules wired in this way, and we can start the whole system by pressing the run in our clock module.
This is a test recording to demonstrate
this plays this recorded file. And this file, so you see the visualization of the audio file in this scope module. And with this file, we generate this envelope, which is causing other actions. For example, playing here these additional files, additional audio files. They are selected here. We can activate also the audio from an oscillator, so we can trigger an oscillator playing these tones. Let's decrease the test recording. We get some rhythmic combinations. Everything is controlled by this envelope from the test recording. And last but not least, you can add here some percussion. That's also partially triggered by the information of our envelope. Okay, now we want to rebuild this patch, this VCV Rack patch together. But before we start, you need to go to the VCV Rack website and go to the library, where you find all the modules that you can add to your VCV Rack. To be able to do this, you need to create an account and log in. I assume you need to do this even to start VCV Rack on your desktop. So you have an account, you are logged in, and then you see all the modules here. And for the example that I show you, you need a list of modules. I added the list in the comments below this video. To install them, you need to find the provider or a name of the module or the developer. So the developers, that's the first part of the name. So here, for example, Algorithm Art has developed this clocky module. And if you want to install all algorithms from all modules from Algorithm Art, then you just have to click on this plus button. And then it changes to the subscribed version. And if you want to unsubscribe, you can just press again. But if it's blue, then you are subscribed to these modules. Means they will be installed to the VCV Rack automatically after you started it. That's why I changed to the VCV Rack again. If you have selected the modules that you want to install, then you will see here a red circle somewhere here at this library menu after you started it again. And then you can update all the installed modules. Then press update, please. Then VCV Rack will download all the modules and install them. After this process is finished, you need to close VCV Rack and open it again. And then you have installed all the modules. As mentioned, you need to install the modules that are listed in the comments below this video in order to follow this tutorial. After you started VCV Rack, usually you start with this setting, or you should probably see these modules. So that's the predefined start of the rack. What you need to understand is, first of all, the audio settings, so you can use this test setup to see if it works or if the output of the VCV Rack is working on your laptop or on your computer. At the moment, here we have a MIDI input module, and that's using your keyboard as a keyboard to play notes. So you can do this if you press here, for example, the lowest Joe, the X, C, play some notes. So here we have some voltage controlled oscillators, filters, and envelope or function generators. That's not important. You just needed to test it. So if you press, for example, the letter C, then you see here in the audio output, it's, at least in my case, it's set to ASIO. That's an audio driver. Usually if you don't have an external audio interface or a sound card dedicated, then this will not work. You may change to direct sound, at least on Windows. That's the setting that works, but you still cannot hear anything because here I have not selected a device. So press into this writing and I have to set here these speakers. And now I can hear this tone. So you definitely have to hear this as well. And here on the side you also see a description how the whole thing works. But after you've done this, you can here play around a little bit on your keyboard, and now you have a little synthesizer. But we don't need this. Therefore, please delete these modules. Just click on them and press delete. What we will, you can also go back and forth with Control Z and Shift Control Z. Here you have these typical commands. So these things we don't need. So these three modules you can keep. Okay. Before we start, just a comment. Under the engine, you can set the performance of the VCV Rack. Maybe it depends on your computer. Maybe you will have some stuttering of the audio. If you use more modules, this may happen later. Then you can adjust here the settings concerning your CPU usage. So you can use the lowest CPU, then your computer is not needing that much resources. But if you hear some stuttering effects or some delays, then you may increase these numbers to use more resources of your computer. You should also have you shouldn't increase this audio rate, so keep it at the lowest because that's fine for you for now. Usually we don't need more. And you can also change the frame rate of the update rate of our interface. So I think 12 hertz is fine. Okay, but now let's start with creating our patch. So what we want to do is we want to import an audio file, some file that you've recorded, or I will provide you also one. But to do this, we can click with the right mouse button here on some empty place. And you see here now this menu with all the modules that you've installed. So I installed here already a lot of modules. Hopefully you don't have that many. You don't need that many. And here at the left side, you have this menu that have these keywords, what kind of or type of module you may use. And at the bottom, the manufacturer, the programmer, the company, or the people who developed it. So first of all, we need this module that can play our audio file. Therefore, we go down here. So these are two different menus to the sampler menu. And my sampler menu, that's this Voxglitch repeater. That's what I need in the beginning. Therefore, click with the left mouse button and then it's automatically placed on your rack. What I will need as well is the clock module. Again, right mouse click and then I go upwards. Clock module, no clock generator. By the way, you will only have these modules if you have installed the modules in the library, as I mentioned at the beginning. Please be sure that you have imported or installed all the developers that I listed. So that's, for example, from the developer Impromptu, this clock module. So sometimes it places it somewhere, and you have to scroll. So with the mouse wheel, it's going up and down. If you press the control button, you can zoom in and out. And with the shift button, you can zoom left and right, moving your mouse wheel. Okay, so I place this here. Now I have the clock module and the repeater module. That's my sampler. If you right click on the sampler, then you find here these sample slots. So I have 5 sample slots. And now I want to load one audio file, WAV file. Then press on the empty slot. And in my case, I have stored it on the desktop in the test samples. And where do I have it? Test recording. Here we go. Just select it and open it, and then you have loaded your test file. You see here in the first slot, you should now find the name of your test file. You can also load the second one. That's what I have here. Open it, and then right mouse click, and you see you have filled 2 slots of your samples that you can select here with this wheel. You can then choose between them. We will see this in a minute. Okay, now what we need to play the sample is a trigger. So a trigger means the signal that causes my sampler to start playing the sample. That's why I need this clock module. We have here 3 outputs, 3 different clock speeds. So the global speed is set to 120 beats per minute, this BPM. And you can then multiply or divide this global beat. So let's divide it, let's say by 8. And then that's our third row is the clock number 3, which we use as a clock input for this repeater. So to draw this connection, just click with the left mouse button where you want to get the signal from and release the mouse where you want to place or where you want the signal to go to. That's our virtual control voltage. And by removing the cable, you just can press the right mouse button, then it's deleted. Left mouse button, you draw it. And if you press the control button, you can draw a second output from this clock, or from an output to an input. Control left mouse button. Okay, but now our sampler is playing our test recording every time it gets a trigger. So, and you see this green light. This means it starts the trigger, or in this case it's a gate. So a gate opens as long as the green light is showing, and then it closes when the green light is going off. And here we have our outputs. We have a trigger as an output. That's we don't need. That's the audio signal that we need. That's our output. And we use this output to send it to our scope. So the scope is a visualizer, so we can see certain information about signals. In this case, it's our audio signal. So here we see, something is happening. That's the sample that's playing. So you can change here the time scale, so then you can see more or longer period of time in your scope. You can adjust this, also the X and Y position and scale. But we don't hear anything yet. If you want to hear it, you have to connect it. So press Control left mouse button and link it to the input of your mixer.
Demonstrate. Hello.
And now
this is test
we can hear
demonstrate.
our sample.
This is test recording to demonstrate.
And you hear every time this gate starts again, is triggered, the sample starts from the beginning. If you go to speed division or the clock division 2, so you see then it's starting again and again. And if you want to play a longer part of this recording, you just have to adjust it to a bigger division.
VCV Rack.
Then it also plays a longer sample.
This is test recording.
Okay,
to demonstrate
what we want to do now, we don't want to play the file, we want to analyze the file.
This is test audio
To analyze it, we need an envelope generator. So this generates an envelope for our audio signal. It's better to understand it as we see it. Just load. So here, by the way, you reset your filter if you have selected, or here you can also search for keywords and reset. Deletes all filters, and you can now move to envelope follower, because we want to generate an envelope by following our audio signal. Follower. And I'm using this one from NYSTHI, envelope follower. Mouse click, then it places it here on the canvas below our scope. And what I want to do is I want to feed this audio signal in the signal in position, this input.
This is test recording to demonstrate the
and
processing
just
possibility.
Turn this off, so you can, here you have the global level, the gain or the volume, and here you have the level of this channel. So going down, then we don't hear this recording all the time, which may be a bit annoying. So now we have the signal in our envelope follower, and we get here an envelope out or a signal out. We want to have an envelope, so we place this in here. And now you see at the above here this magenta or reddish magenta colored envelope curve. It's not very clear. That's why we can, for example, offset it a little bit, so then it moves it up, and we can smoothen it. We can also increase it here. So we see it follows this audio signal quite precisely, but we want to have it more smooth. So turn up the smooth parameter and the release. So this means attack means how fast it increases if there is a signal in the audio, how fast our envelope increases, and the release means how fast or slow it releases or decreases. So this reddish curve, this magenta curve here. So that's why we go back here. Now we have a nice envelope that increases relatively fast, and then it needs some time until it goes down. So that's a nice curve, and that's now the curve that we will use to trigger other events. How we do this? What I want to do is I want to use only certain, or I want to divide this envelope curve into some segments or into divisions that make more sense for triggering something. Therefore, I add here, just reset the filter, I add a quantizer. So you can, for example, type here quantizer or quant. And where is the one that I want to have here? That's the ML modules quantizer, this blue one here. The quantizer generally is using a signal and quantizes it in note steps. So here you see these white and black keys of a keyboard. But we can also use this for some other purposes, just to have some segments in a certain distance. This is what we want to have now. So I put here the output, the envelope output, into the input of my quantizer. And now you can select some notes, but don't think in notes, in terms of notes. These are just step sizes for our divisions. To see what happens, you can copy the scope. Either you place a new one in the same way as we have placed modules, or you press or you click left mouse click on this one and press Ctrl D. It's double, and then you copy it, or you right click on a module and duplicate it. Then you get it again. Then we can place it here. So the scope is always very helpful to understand what's happening. So just put in here our signal again. Maybe place it here. This is our envelope curve, so same color as we have here. And if you use the output from this one, then you see here this, you don't see it very well. Let's zoom in. That's now a stepped output. But it's very closely overlaid. Therefore, we use an offset component to move it a little bit up and to scale our stepped envelope curve. Therefore, press here the right mouse button and check the reset the filter. We want to have an attenuator, and here that's this Bogaudio offset generator. Yeah, that's the right one. Before we put it into the scope, we take the output of our quantizer in the input of our offset and then send the output to the scope again. Looks quite the same. But we can now offset our stepped curve. Here you see the offset. We can also reduce the number of these steps. So if you only select a few of the steps, then you see you only have very few steps in this curve. And if you increase the scale, then we have a much better curve that is stepped here. So usually the maximum voltage is 12 voltage, so you can still increase it a bit, but don't go over max 12, so this looks fine. Okay, so I hope that's clear. So we use this red curve and generate the blue curve by our quantizer. Then we offset it and scale it a little bit, so we get these steps that we use next. So what do we do with the steps? This is now used as a kind of a variable that shall play other audio files. How to do this? Therefore, we need another sampler. Right mouse click in the dashboard and then go to sampler again. And now this time we want to use this wave bank. So we want to play a lot of wave files. And we need to tell this component where to find the files that we want to play, similar to our repeater sampler. Therefore, right mouse click on this component, and then we select the directory containing wave files. So only wave files work, no MP3 or something like this. In my case, I stored these files on the desktop in a folder that has no special cases, no blank cases. So be sure that you use that the path to the file has no empty spaces or special cases, just normal names. That's important, and I just use this folder, test samples, and press OK. Then you see, if it works, you should see the name of one of the files that are in your folder. In my case, it's glitch 001.wave. Okay, here we see two inputs. We can either trigger this one. If I do this, for example, with my, where do we have a trigger? For example, here the clock trigger, I can trigger this wave file, and I can use the output and send it to this place. And then you can hear this is this very short wave file glitch. These are just some kind of tones that's playing now every time it gets a trigger. But what I want to do is I want to use this blue curve, so this signal that I get from my quantizer after the offset, and select a wave file in this folder. So if I take this output, same one that you see here, put it into this input, then you see this shows you that it plays different wave files. And this address is defined by the voltage that comes in here. So that's what you can now adjust. If you decrease the scale, for example, it will choose different files. So here, different files are playing. Also, if you change the offset, it down, then again, different files are playing. Maybe put the offset to 0, then we play all the first files and have a bigger offset. Then we cover the whole range and get a lot of different files. So the more steps that you have, the higher the probability that you get different files, because then more addresses are selected, more different files are selected. They're always played once and then it plays the next one. So they are not re-triggered while here these different files after each other's playing. These knobs, they let you change the start point. So here you start from not from file 0 in your folder, but from a file so it's a kind of an offset from your first file to the end. And here you define the end of your numbers. So now I've selected a quite small range. So here you see my addresses are only changing between something like 14 and 17. If you make this very small, then it's not changing that much anymore. So only a small area of possible files. So I think I have 100 of these wave files. Now I allow this bank to play a lot of files. Okay, so now just to recapitulate what we've done, we used this test file. I'm playing this together now. Did you hear that there is really something going on? If this file is playing, then also increase this number.
This is test recording to demonstrate the audio processing possibilities with VCV Rack.
Now there is a gap and nothing happens because nothing is playing here, or maybe always the same file. Only if this test recording is playing, something happening here in this bank.
The audio processing possibilities with VCV Rack.
What you can do here as well is that you loop something, that you loop the file that was last selected, then it will never stop. Also, if this is pausing, then you play the last selected file. But this may be a little bit irritating. Okay. So far, I think, or I hope you have understood the basic idea of this using a recorded file and process it, analyze it, and cause some other modules to, in this case, to select another audio file and play. But we can do much more with this principle. For example, as I've shown you in the beginning, we can also play an oscillator, and that's what we want to do now. So we can add here an additional module. What I want to do next. To add an oscillator, we go now again on into our module library, reset the filter, and select oscillator here. Here you should find, where is it, this one, the macro oscillator 2. That's what we want to have. And I will show you later how it works in detail, but here these gray buttons, you can select different notes with these buttons. Well, let's first connect a trigger. Before we have something, we can use just a clock signal, put it into the trigger, and we use the output from our quantizer. So this output, just press the control button and take the second output to the volt per octave input of this oscillator. So now our quantizer is used for the purpose for which it is made, to generate notes. So note values that are in a different, in a certain distance to each others, and we trigger it. So this is what happens if you press a key on a keyboard. Then you trigger the key that has a certain value, a certain note value. So the pitch, so to say. And then we take the output and take it to the input. And that's what you hear. Our oscillator is playing. It's kind of a macro oscillator. So this already is internally set to play something similar related to some instruments. And these instruments you can switch by pressing here these buttons. So on the right side you have banks for drums. So these are more drum tones, different ones. And on the left side you have more this kind of instruments like string instruments or something, or keyboards. So what I select is here the second last one. This plays many notes at once, or chords. So you press 2 or 3 pads on the keyboard, then you get a chord, and that's the chord mode here. And with these knobs, you can play around with these knobs on your modules just to find out what they are doing. So here we change the frequency, as the name says, harmonics, you change the harmonics of your chord, the timbre, and you can morph between different settings of your oscillator. That's not important, I just play around and listen what's happening. In this case, that's a special oscillator that has multi-functions per knob. If you right-click on the module, then you find here Edit LPG Response Decay. So then if you select this, these knobs turn blue. And here, that's the decay of your notes. So this means the release, similar as we have it used for our envelope. So how long your tone that's played will need to release, so to disappear, how long it needs that the volume goes down. That's the decay value here. If you want to have shorter notes, then you can go tick, tick, or longer notes, then it's long. Okay, that's it here. Right now, so response, that's this knob. Don't need to change it. Just set it somehow. You can also control these knobs by taking some inputs from somewhere else, whatever you want to use. For example, let's use the raw input of the envelope, and for example, as we've discussed it, put it into the morph, but nothing is happening. But if that's a kind of an attenuator that controls how much of this changing envelope curve affects this knob. You can do this for the harmony knob here as well, there is no attenuator, or for some kind of FM, it changes the character of the sound, or for the timbre. Then you can hear that it's changing following the envelope. Just to note it, it's not important for us here, but really experiment with these modules, play around with inputs, and then you will learn what they do. Good. So now we used the clock signal from our normal clock to trigger this event. But that's relatively boring. What we can do as well is that in this case, in our quantizer, we generate gates, or we generate a gate every time where we have one of these steps when the quantizer is changing the note. So let's try to use, so if we don't have a gate, then it's playing without any interruption. And if we use this gate, then what you see is every time these steps appear, we get a trigger, and it's playing very, very often, very fast. We can reduce this if we change here the number of steps. Still playing fast, but not that fast anymore. And what we can do as well is to change the length of the gates. And that's what we want to do as well. In order to reduce this relatively chaotic triggering of our oscillator, we need a component that allows us to control the gates. So for example, the length of a gate in more details. So here we can just use the gates that are produced here, but now we want to fine-tune these gates. Therefore, go to your modules, to the library, and what we need is the envelope generator. So you can find it again on slew limiter. If you select this one from Bogaudio, then you get this VISH component. Select this one, and it's placed here. And you see we have here parameters for rise, fall, and the min gate length. So rise and fall is again attack and decay, or somehow how long it needs to increase or decrease. in this case our gate signal. So what we want to do is we want to use this trigger into the gate and put it in the gate input, and we take the gate output and set it or connect it to the trigger input of the oscillator. Now it's quiet. Why? Because here we have a relatively long gate length. It's always good to copy our scope and have a look what is happening. If we use it here, then you see, there is a very long gate signal. Sometimes it's going down, that's when we hear something. But usually it's always on. So means we probably have to reduce these numbers. So if you decrease all the numbers to 0, then we will probably hear something again. Okay, so if you set everything to 0, min gate length, fall and rise, then we hear our nice chaotic pattern. Good. Now what you can do is to increase the min gate length, so the minimum gate length. If you slowly increase it, then you see in the scope, and we don't have that many. If I decrease it again, so here you have many gates. If you zoom in, and down. So these are our gates. Every time it's up, then it opens a gate, means it plays the tone in the oscillator. And if you increase here this number, then you see we reduce the number of gates, so they will become longer, so more will be put together. So our chaotic pattern is shrinking to something more ordered. Okay, you can play around with this parameter until you like it, and you can control the rise. So this means now it's immediately turning on or off. For the trigger signal, that's fine. There will not be an effect, but we can later shape the signal, the audio signal, with the so-called voltage amplified, voltage controlled amplifier. It means you can make it louder and lighter and controlled by curves similar to this. But that's that's for later. Okay, now we have something that can be used to control our pattern in more detail, but it's still relatively chaotic. But for now, we keep it as it is. And we can have a look at it later to make it more ordered. Maybe for our last channel, you can put these things together now, playing these samples and this chaotic oscillator. And let's move to my nice test recording. By the way, here you can also start the start position of the test sample of the test file, and you can also change it to another one. We have loaded here 2 files, so that's top of different recording from one of my kitchen tools. If I increase this knob or the value here, now you see I change it to something else. Play a different file, you get a different signal, it causes different actions, and you control your the whole chain in a different way. So you can exchange the files, or you can do live recordings as well if you have the right equipment, or you have different recorded files just to experiment with and see what you can do with it. But now let's go back to our initial recording. But it's more differentiated, so we see more things changing. Right, now just let's play around with more modules that we can put together. We can, for example, use a drum module to make some kind of drum patterns. If you go to your drum modules, then you have here this very nice Erika synth module, Pico drums. Here. And again, we can use, for example, here these triggers. How we use this one. put it into either trigger 1 or trigger 2. You can trigger 2 different drums from here. And I'll put it here on input. Now you see something very strange is happening. That's because we need to clean up this pattern as well. So we duplicate this module and first put it in here and use the output. And so now it works. It's a cleaner pattern. And here with this knob at the top you can select banks. Let's look for something like a snare. Let's scroll through it until you find something that you like. This one. If you click on this button you can change again various parameters. So the green one, what it is, pitch, and the red one, that's probably decay, and the yellow one is the volume. So you can change this drum sample that's playing here in a way that you like it. We can also use another clock signal to trigger here, for example, this one. So you can trigger 2 different drums. And you can change here this knob. So now we are at drum and change the drum. Oh, that's right, that's drum 1. Something like a kick drum. And we can also look at this pattern that we have here. Okay, so it's relatively chaotic, but I think you understood the principle. If you want to have it a little bit more ordered, you can use these clock signals and, for example, trigger only the oscillator or the drums if the signal that we receive from our gate pattern here, if it's the same in the same time step as our clock. We can do this with a logic module where we have an AND logic. So if you entered your logic, then we can again use this Bogaudio logic Bogaudio bool. So the Boolean logic where we have here an AND output. So what we can do, for example, is turn off all this noise here and just check our drum patterns. So here you have a switch that says if it's inclusive or exclusive. So if we have it down, then it plays both triggers. If we switch it from inclusive to exclusive, then the second one is triggered only if the first one is triggered. So you hear this kind of kick drum is not triggered that often. Anyway, what we want to have now that this drum pattern that we use here for trigger 1 is only triggered if it corresponds to our clock signal 2. So if you put this in, so here you hear a very regular pattern. And we can use this to say, okay, only if they are both on, so if it's in this kind of rhythm of this clock, only then we want to have our drum playing. Okay, so now you hear that's now synchronized to our clock. So only if the AND is true, then it's playing. Not in this weird rhythm that we have had in before. You can use your other logic outputs as well, so the OR signal or the NOT signal. You can experiment with it that you like. And what I want to do now is I want to change these. So I want to have this here. For another. So let's, okay, this one and the other one shown here. So number 1. And then we can say it shall be exclusive. Then it's becoming a more regular pattern, and that sounds more like a drum pattern. Okay, but everything that I wanted to show you is that you can use the gate patterns that's coming from the signal that's caused by our test recording here to use it, or to use it as trigger signals for, in this case, drums, or as we've done it here for our oscillator, where we can, by the way, use this end signal now as well to get some more. To get some more regular patterns. So now here it's exclusive, so here this snare is only playing if not the kick is playing, and we use it also as a pattern to play this macro oscillator. We can do this together now with the samples that we are playing randomly. Then we have a nice chaotic piece of music. What you can do as well is to add some effects to have even more fun with your patch here. For example, a delay effect. And if you have installed the corresponding modules, then you have the delay. I'm using here this one from Alright Audio. That's very nice. Then you can use the output, feeding it to input of your delay module, and then after delay, use it as output. I want to do a test recording. So now it becomes even more chaotic. Here you can set the parameters for the delay, you can play around with it. Maybe we have to use this in a more regular way. So you can copy your logic module and have shorter sequence of triggers. So let's have this slow clock every 4th beat, or this kick pattern, and we use it with our gate pattern. So only if both are true, only then we want to cause here the trigger for our oscillator. Okay. Here you have this dry wet. And the number of repetitions of your delay. So we'll type, we'll just play around with it until it sounds better. Okay, so now you get a kind of a fancy rhythm, which is primarily controlled by our input file. So that's really the interesting aspect. Again and again, that's what I really want to show you. And you can control a lot of things in this patch, really based on the analysis of this audio file. And just for fun, we add here reverb to make this even fancier. Reverb, just reverb, something like this. So you can really play around a lot with these patches. Output to the input, output to the output. And then you can have fancy effects here. For example, for your drum pattern. Okay, anyway, that's really not important. But you see that this opens up a galaxy of possibilities, and there are really a lot of modules that can produce very weird things. So the basic concept should be clear. So you use this recorded file to analyze it, to generate this envelope that you can control the parameters of the envelope follower, and you can offset it and play around with all these parameters. But the key aspect is that you use then this information that you can generate from the envelope to play these sample files, to trigger an oscillator, to generate drum patterns with various combinations of other modules. You even can add effects for weird processing of your sound files, and then you feed it to your output. And as soon as you change the input, which can be, for example, a different recording, different field recording, and if you do it on site, if something else is happening. So, for example, I change my input signal to this one, and I will change this speed, then it repeats more often, the start position, so you can play around with parameters here as well. But what you do is you change the envelope, then it has an effect on the output. That's really the key idea of the whole thing. Or you have here longer breaks. You have periods where it's more quiet. Okay, so this was basically the example. I provide you the whole thing just for the completeness of our example. So let's reduce here the background noise. If you have a field recording, what you need is an audio interface. If you connect the audio interface to your computer, to your laptop, then you may change here from direct sound, for example, to this ASIO driver or this Wasapi. ASIO is usually the best solution. And then you can select here your audio device, the audio interface. And if you connect the microphone to this interface, you get here the input signals, the input audio that's live recorded from your device. And then you can use the source from this input instead of our recorded file. And then you have a live system where you can really in real time record something and use it in your envelope generator to cause other things in your patch. So this patch is just an example. Of course, you can build something completely different. It just illustrates the principle how you can control things with the VCV Rack, and that's only one small aspect out of the endless possibilities. So if you're interested in getting more, we can do even more. Or I can do more introductions to additional aspects. Just let me know in the comments to the video if this would be of interest for you. So, wrapping up, clock module, either audio signal recorded or live recorded via an audio interface, then processed via an envelope follower, generating steps, and then doing something with this envelope or with the processed envelope with the step curve to cause other effects. So playing an oscillator, playing other files, other audio files, drums, putting everything together and send it to your speakers. That's it. And be sure that you understood what happened in our scopes, because this is the visualization of what's happening in our control voltage. I hope you enjoyed the very rough and fast and general introduction to the VCV Rack and got the basic understanding of the possibilities And as mentioned in the beginning, there are more than 2,000 of these modules. Of course, many have very similar functionalities, but it's really a universe of possibilities that opens up as you start exploring these modules and what they can do, and also the possibilities of this modular synthesis, where you can generate experimental soundscapes or very traditional melodies or whatever you want to do. So it can be complete noise as we have it here more or less, or it can be more precisely musical related things. That's really up to you. Experiment a little bit with it. Maybe you find something that you can use for your project. So with this, good luck with the VCV Rack. Enjoy it.